Now, he's talking about something called incidence axioms on lines. What are these two figures indicating? Let's understand. He took a point, okay, in between. I'm just drawing a larger point. It can be as small as a dot, okay. And he drew multiple rays originating from one point, right? If you can see the figure, he's drawn multiple rays that are originating from one point. What is he trying to tell us? He's trying to say, from one point, I can draw as many number of rays as possible. If you assume this to be the sun, this is how the sun rays evolve or they come out, right? Multiple rays in multiple directions. You cannot even count them. Now, if I talk about this figure underneath it, what is it talking about? It is basically a line. How do I identify it and not a line segment? Because of the arrow marks. It says that it is continuing indefinitely, right? It does not stop. There is no end. And this line has
it can extend from both the sides.
Exactly. There is no endpoint on either side. It extends on both sides indefinitely. We are very clear. A line segment, I am taking 2 points, connect together. This is a line segment. There is no end either on either side. This is basically a line. As simple as that. What's a ray? There is one point from which something originates and travels indefinitely. A ray, for example, the sun. Right? Is the difference clear?
Yes, sir.
Right. So what do we see here? If I draw infinite number of points so close to each other that you do not see the gap, we are talking about a line. Very clear?
Yes.
Now, the number of points that are drawn are infinite. That is, you cannot count them. As simple as that. That is what he is trying to say. And if I am talking about, say, I take 2 points, point A and point B. Now, guys, can you tell me how many lines can pass through these 2 points? Anyone?
Sir, one.
Anyone with any other answer? Pardon? Anyone with a different answer? I've got one as an answer. Anyone with a different answer? Can you hear me, guys?
Sir, rays.
Yeah, Bhavya, I guess your message is right. One point that is on one side and it can extend indefinitely. That is the ray. Yes, you are right. Whenever you use the word ray, think about the sun. There is one point, one source of light. The rays go in different directions indefinitely, as simple as that. Now guys, coming back to this, if I have 2 points, there is only one that can pass through these 2 points, even if I extend it on either side. Very clear? Any doubts over here, guys?
No.
Okay. Now we're going to learn a very interesting topic. Now guys, who can tell me, have you come across the statement, sum of angles in a triangle equal to 180 degrees?
Yes, sir.
Now my question to you.
No, I mean, I've learned it in school, but you didn't tell us.
Yeah, exactly. That's the reason I asked you if you've come across it earlier. Now, my question is...
Yes, sir, but I did not understand it.
Right. That's what you're here for. Now, can you, just because you were told that the sum of angles of a triangle are 180 degrees, you just memorized it. Did you ever think why? Can anyone tell me why? Why does it have to be 180? Why isn't it 200? Why isn't it 300?
So can I tell?
Yeah, I want to answer.
Sir, because the bottom line segment is straight, meaning that it's a 180 degree angle.
Okay, very good. We are starting somewhere. Okay, I have a start. Now, I'm talking about a triangle, right? if I name this 1, name this 2, and name this 3, what is the angle 1 plus angle 2 plus angle 3 is always 180 degrees. Correct? This is what you learned. Now,
Yes.
someone got
Sir, can I tell?
Yeah, please.
Sir, because two angles are, I guess, both two of the angles of the triangle are 90 degrees.
Okay. Look, if you're talking about 90 degrees, if I draw something like this, I am saying this is a 90 degree angle. That means it should be a right angle triangle. Right angle. But a triangle can be formed in this way also, right? The shape of the triangle is irrelevant for me. Unless and until I have 3 points that are joined, I form a triangle. Given the condition that the sum of the 3 angles should be 180 degrees, there's another aspect to it where it says the sum of 2 sides should always be greater than the third side. We will come to that. But now let's focus on the angle part of it. Now guys, someone told me straight line. We have a straight line. The angle of a straight line is 180 degrees. Correct? This is what you know.
Yes.
Can I prove that the sum of angles of a triangle are 180 degrees? Is there any simple way? We have a lot of complicated ways. I can get you a 4-page proof of why the sum of angles of a triangle are 180 degrees. But is there something very simple and very logical by which we can understand? Now look at this triangle very carefully, guys. What am I going to do is simply open the triangle. We know that if I have a straight line, this angle is nothing else but 180 degrees, and if I double it and make it in the form of a circle, the entire angle is 360 degrees. This is something you guys, am I right?
Yes, sir.
Now, what am I saying? Let me open the triangle up. How do I open this triangle up? Say I have A, B and C is what I have named it. Okay? BC is my base. Okay? A, B, I break it off and I make it sleep. That means this AB came here. Okay? I opened it up. Right? Similarly, I break AC and open it up this way. Okay? What did I do? There was a triangle. I did not change the base. What was here, I broke it and I got it to the other side. What was like this, I broke it and got it to the other side. Very clear, guys?
Yes, sir.
Imagine what is going on?
Yes, sir.
Correct? So
Yes, sir.
something like this now we have in the form of 3 lines, right? Which are connected, obviously. Cool? Getting into your head? So what did a triangle become? When I opened the triangle up, it simply became a straight line, right?
Yes.
You all agree with
Yes,
me?
sir.
Now, what is the angle that is formed at a straight line? Isn't it 180 degrees?
Yes, sir.
Do you
Yes.
see how simple and logical this was? Sum of angles of a triangle is 180 degrees. We always memorized it. Did we think why? Did we think how? Did we think about a simple proof?
Sir, I only thought about it just now when you asked.
Exactly. I simply opened it up. I did not do anything. There is another proof. There is another way of determining or understanding why the sum of 3 angles is 180 degrees. As we move into core geometry, I will come up with that because that has certain other concepts you have to understand. Cool? Now, someone spoke about the 90-degree triangle. Now, even if I take this 90 degree, what am I doing is simply opening up this side again. Say it is AB. I open up AB and make it lie down. So what happens? This is how I get it. Now I have AC. I open it up to the other side. It continues. Again we have a line. The angle on a line is nothing else but 180 degrees. That is the reason the sum of 3 angles in a triangle are always equal to 180. Are we very clear?
Sir? Yes, sir. Sir, so 360 degrees is also a straight line, right?
No.
No.
Yeah, when I take a point, okay, and I make a complete rotation, it is 360. But am I making a complete rotation? No, I am only talking about the angle on the line.
Yes, sir. So, even 360 is a straight line. So why can't it be 360?
No, 360 is not a straight line. Okay. So look at this figure. When I talk about this line, I can either have an angle over here. How is an angle formed, guys? सबसे पहले, if I take one ray like this, and from the same point I have another ray, this is an angle. I think the next slide is going to talk about that. Now, I need two lines to form an angle. Now, what are we talking about? If we take this as a point O, and I extend this entire thing becomes 360 degrees. Around a point, everything is 360, but I am only going to take the two rays in order to understand the angle, right? I am talking about this angle only. This is something that is called a reflex angle. We will come to that. Even that is a topic or a concept that we're going to discuss today. But I'm talking about the angle that is formed by two rays. What did I do? All these were rays. I just opened them up in
Sir, your voice is breaking.
Yes, sir.
there might be a no issue here and then because there's a power cut, etc. Can you hear me now?
Yes, sir.
Cool. So what are we talking? This is the line and this is the point. If I have to extend the entire thing, that is 360 degrees. But I am talking about only the line because I have opened up the triangle, because of which I have got these two extra lines. That is the reason straight line gives us 180 degrees. Cool? Are we clear till here? Guys, yes or no? Are we clear? Before, can we move on?
Yes, sir.
Okay.
Yes.
Right. Now we have a concept of collinear points. Yes, what are collinear points?
Points that lie on the same line or line segment.
Very good, very good. Anyone else with any other answers?
No, sir.
Everyone agree? Now, if I tell you something, okay, what you have told is right.
Sir, can I tell?
Yeah. Tell me.
Collinear points, I guess, are Sir, can you hear me?
Yeah, I can hear you. Go ahead.
Yes, sir. So I guess collinear points are the points which come in a straight line.
Good, exactly, very good. Now, if I take a straight line and I keep drawing points on it, irrespective of the number of points I draw on a straight line, if all of them are the same straight line, they are called collinear points. As simple as that. Now, can a triangle, if I tell you there are 3 points which are collinear, my question is, can a triangle be formed? Think. I just tell you that there are 3 points which are collinear. My question is, can you form a triangle? What is a triangle? First of all, what is the fundamental idea of a triangle? The closed figure, right? There are
Sir, we can, sir.
There are 3 points. I am going to connect them.
Sir, no, sir.
It's a triangle. So you are saying a triangle cannot be formed if I say the 3 points
No,
are
sir,
collinear.
we can form, sir. Sir, like we put that. Sir, if the, for example, I'll take the same example on the screen. So if we take the Q point as the center point of the triangle, and if we just bring R and P up, and join them both, then we can just form a triangle.
Correct. I was expecting this answer. Now, go back to the concept of collinear points. What did I say? The points should lie on the same straight line. Same straight line. Now, in a triangle, do we have one straight line? No, we have one, we have two, we have three. But what is the fundamental definition? It says on the same straight line. Here, look, I took just one straight line. Did I draw 2, 3, 4 straight lines? No, right? In the previous slide, when I was trying to explain why the sum of three angles are 180 degrees, I tried opening it up. If you try closing the same figure, you do not get one straight line, right? What is one straight line? As simple as this. But when I'm forming a triangle, I have one straight line, two straight lines, three straight lines, right? Because of which I get 3 points. Now these 3 points aren't collinear, right? That means if there are 3 points which are collinear, that means they're lying on the same straight line and the triangle cannot be formed. Is that very clear now?
Yes, sir.
Okay, cool. So what is the area of the triangle? What can be the area of such a triangle? 0. Obviously, when there is no triangle formed, how can we have an area? What is it? What is the area? This part inside the triangle, right? Whatever I'm shading or coloring. Is this idea very clear?
Sir, so whatever I said, was it correct?
Can you repeat? Actually, I'm using 2 screens. I do not know who's speaking actually. Tell me.
Sir, so whatever I said, was it correct?
What did you say? Can you repeat it?
Sir, I said that if we take the Q point as a center point and if we just put R and P up diagonally, then and if we join them both, we get a triangle. So was that correct?
Correct. Your point is correct. But when I relate it to the collinear point concept, it changes the entire idea. Because when I'm talking about collinear points, I'm talking about one straight line only. But to form a triangle, we have 3. Do you get the idea now?
Yes, sir.
Okay. Priscilla, do you have any doubts?
No, sir.
Okay.